Hello everyone, welcome back to the channel. This is another video in the Decoding Traces series where I show you how to manually decode traces. Now, if you haven't checked out the other parts of this series, excuse me, definitely recommend to check it out because part 1 definitely covers the basics, and as we move along, this will be more and more advanced. So today's example is I would say a good example because it has it is a nested tuples. So basically what that means is it's a collection of collections, and we also do not have the ABI, so we're just blindly guessing here. And also it involves strings, so additional rules would need to be applied right here. Okay, so what is a nested tuple? So I already have the query written out, so I'm just going to be talking through them, but hope you can follow along. So a tuple just means like a collection of something, right? It can be, let's say a person is a tuple, and then it can have name and age, right? So name and age is part of the person, right? So this is a collection of collection of information, right? So a nested tuple would be, let's say you have let's say school, right? And then under school there is, let's say, students, and then students have name and age, and so this would be like your standard tuple, and then nested tuple is like this whole thing is under something called school in this case. Doesn't really matter too much, it just means there are more offsets to consider. So let's see how we would decode it. Now in today's example, I'd like to go through a name service on Monad. So in case you missed it, Flipside has Monad testnet data now. And so there is this protocol called NAT, name service. It's essentially the same as ENS on Ethereum. And if you look at the ENS documentation, there, after you have minted a domain, there is a way for you to add attributes or add metadata to your domain, right? In this example here in the docs, they are showing you how you can add nickname, bio, website, so on. Yeah, and then I guess the important part here is that once you confirm your details, it's actually a transaction. You're posting the transaction on chain, and so all the details that you've updated is actually on chain, and there's a way to decode it and be able to find out what exactly those details are. So I thought, since this is similar to ENS, it might have something similar, and so I looked into it, and indeed it does have something similar. So I'll take you through how I found it. I of course went to like the Monad Explorer. I believe I went to this one, right? Click on NFTs, and then the NAT name service is part of the list here. And I'm just clicking into, let's say this first one over here, and I want to get I want to see all transactions related to this particular NFT. So first I look at mint, and mint has no information regarding the attributes because it is just minting the domain name. And so if you see right here, this piece of hex here, if you change this from hex to string, so hex to string, this will give you, what's this? This should give me this Jolly Bay, which is similar to what we see on here, right? Jolly Bay. And so how do I find like if the person actually made the attributes? You just have to like click one by one and find. But I do see this transaction over here, right? And this is by chance that it was easy to find. Wait, is it this transaction? Okay, it's not this one. Is it this one? Let's see if I can grab a sample. Oh, okay. It's not this one? Okay, it's not this. Where did they make that change? Is it this guy? Three zero. This one? So yeah, this is what it looked like for me when I was trying to find what examples. Oh yeah, okay, I think this is it. So the first clue is that if you look at the logs, is very long, and long here because if you think about the attributes that you can potentially add a lot of attributes, and so that's why your logs will be long. And another thing here is you can either use event logs or traces, but I think I went with traces because I wanted to pull an extra information that wasn't available in logs. And so this is what you do next. So the first thing you do is look for a contract if there's an ABI, right? So in this case, the monad, the net domain contract address is this 3019. And if you click on the internal transactions, which is traces, you will see that it made a delegate call to this contract, which just means the original contract is a proxy address, a proxy contract, and it relies on another contract for its functions, right? So this function we will call the implementation contract. And so if I were to click on this, hopefully there is an ABI. And unfortunately there is not, right? This is unverified. And so that what that means is we would just have to manually decode it. And so if you look at my filters over here for traces, I have that exact filter, right? I'm saying give me everything in traces where first is a delegate call, right? I'm ensuring that I am looking at this particular transaction, this particular trace where this person is adding metadata to their domain, and then from address is the proxy address, to address will be the implementation address. And then the function sig just is there to be able to distinguish that this is indeed the particular trace to edit the metadata. So let's see what this looks like, right? Let's go to flipside.new, create a new query. And we don't need all this, we just need maybe this. And maybe, where was the transaction? This one, yeah. And of course you would have to put your put your date timestamps, whatever, because this is still small, so I'm getting results pretty fast. Okay, so standard when it comes to traces, we would apply use this function of cutting out the first 10 characters, start from the 11th character, 10 characters because function sig, and divide all by chunks of 64 characters long. And so that gives us this part, right? And then we can copy this, and I always use this website called QuoteBeautify. Just paste your JSON, and now you'll be able to sort of see all of this in its glory, I guess, right? And then I think for this particular case, I think it would be good if I can paste this into a sheet. Let's see. Oh, nope. Okay, that works. Yeah, cool. So this tells me the index of the array, and then this tells me the value, right? Just like here. So I can just remove this now. I'll just move it to the side. And then this is the transaction we want, so I'm just going to close the rest. And yeah, so from here on out, it's more or less us trying to, or rather me, trying to guess what each of these might potentially mean, right? Because we do not have the ABI, and so we don't know what this means. The only clue we have is some sort of metadata has changed, right? And I'll tell you some of the clues that we can see here as well. So the first clue is that this is 64 characters long, right? It fills up the whole line, which means this is most likely bytes, right? Bytes 32, right? It's, yeah, there's nothing to decode from this. It's just some bytes. It could be an identifier, right? It could be a hash of something we don't know. So most likely we can't use it, we can't really decode it. It's just as it is, right? The next one you would see is 40, and 40, whenever you see numbers like 40, it very highly means it is an offset. It is indicating how many bytes to offset. And so to convert this, you first need to convert from hex to int, because this is a hex. And so 64 to int, 40 to int is 64. And you can always verify this, right? Let's hex to int 64, there you go. 64 bytes, that means this is 2 divided by 32, so this is 2 lines to skip. 3 means, most likely 3 means there are three items in the array, right? So 3 hex to int is still 3. So 3 items in array. And then the next 3 lines would be the offset for the starting of the items. So 60, converted to int, there will be the amount of offset you need to account for the first item in the array. And then 160 will be the second item in the array, and 240 will be the last item in the array. So you can roughly, see how this works, right? Where it's telling you, okay, skip 2 lines, so we skip the first 2 lines, and then the next line tells us there are 3 things in the array, right? And so that's why it's 3. And that's why the next 3 things will be the offsets for the items. So 60 to 96 divided by 32 is 3. So skip 3. Skip 3 here, where you might ask where would you start the skip from? I don't know how to explain this, but the way I think about it is like there is this hierarchy of information. And so after it tells you there are 3 items in the array, the next 3 lines are its own hierarchy almost, right? And so all this information is below 3, and so you would skip 3 from the current hierarchy, which is this. So 1, 2, 3, and the 6th item in the part array would be the starting of the first item from here. Okay, 160, 352. Is this like 11? Okay, 11. So skip 11, and then 240 would be 576. 18. Wow. Okay. So skip 18. Okay. So skip 3 would be this first 3, right? Skip 3, and here is the start of the first item. So start of first item in the array, right? Remember it says there's 3 items in the array, and we see it's 40. Again, 40. Think about offsets. So again, this is another offset. In this case, 40 means 64. That means skip 2 lines. And because this is the first item, this is a beginning of the other hierarchy. So you would skip these two lines to get the next thing. Yeah, let's work on this first. So it's 80. 80 is 128. 128 divided by 32 is 4. So skip 4 lines. So what this tells me is that the first item is actually a collection of things, right? It's a collection of two things to be specific, where the offsets begin here, and I mean the number of offsets you need to account for are on line 6 and 7. So rather than start of first item, I should say start of first item, offset for item 1A, and this would be offset for item 1B. And again, the reason is because when we reach the first item right here, we expect it to be already be the values, but instead we see offsets, and that would mean that there is a collection of things in the first item. That's why this whole thing is a nested tuple, right? Okay, no fear, let's move on. Skip 2 lines, skip 4 lines. So skip 2 lines is here, right? Skip these 2 lines, and this is the start of item 1A. Now the start of item 1A is 6. 6, if you convert from hex to int, is still 6. Let's confirm that, right? Still 6. And so 6 here, we don't know what exactly the 6 is, but it could be a number of things in the array, but it's not likely because we already went through the offset. Instead, we see this huge amount, and because I'm in Excel, it converts into this number, but we can look at the actual raw amount. Where is it? Here, right? Item number 9. Item number 9 is this. So I'm just going to copy this, right? And then paste it here. Now, whenever you see numbers start from the left side and then followed by a bunch of zeros, this usually means it's a string. Okay, and this amount of hex characters is enough to make the string. And so but because in EVM it's all padded to it's all 32 bytes, it needs to be padded to the right so that it fits into a chunk of 32 bytes. And so that is why whenever you see numbers start from the left, this is most likely a string. So I would convert this from hex to string, and it tells me, it's the avatar, right? Avatar. Decoded to string, it tells me avatar, right? I'm gonna say avatar, and which means this 6 here is the number of characters. Right? Tells me num of string characters. Now, because it tells me the number of characters in the string, after you convert it to an integer, it needs to be multiplied by 2, because this is 6 bytes, right? To convert it to a number of characters, you use times 2, and so times 2 will be 12. So 12 characters you will need to substring. So if we count this, right, 6, 1, 7, 6, 2, 4, 6, 8, 10, 12, it matches exactly, and just cut off the 0, and this is 12 characters, and it's telling us the start of the next line, just take the first 12 characters, convert that to string. And yeah, this tells us avatar, right? Pretty simple. What's next? Well, next is we go back to 80 over here. We've already solved for 40, which tells us that it's called avatar. And then now 80 says skip 4 lines. So 80 is part of the 40 hierarchy. And so we're skipping 4 lines would be, I probably should have make the screen bigger a bit. So skip 4 lines would be 1, 2, 3, 4. Skip, start from the next line. And this next line, again, we see like the whole line is full of things. So this could either be bytes or it could be a string. Either way, it follows the same rule, which is before the string starts, it tells us how many characters are there in the string. And so first convert this hex to int, 40, 77 characters. sorry, 77 bytes. So 77 times 2 is 154. So 154. Take the next line's first 154 characters. Now you will notice that 154 is more than one line because one line is only 64. And so what this means is take the next 154 characters after this line. So I should rewrite that and say take the next after this line. And if you count all this, it would be 154 characters, right? If you minus all the zeros. And let's try to convert this into a string and see what we get, right? So first is this one, then next is this, and then is this, minus all the zeros. Boom, there you go. It is a URL to the profile picture, right? You can even look at it. Okay, this is just, it's just the standard picture. Okay. But yeah, so this tells you this is the exact URL. For what you may ask, it is the URL for the avatar. So now we're beginning to see how this all makes sense. First, there is it tells us the offsets, and we notice there is, offsets within offsets, and where we expect it to be a value, we see an offset, which would mean there are more offsets. And the structure here is, first it tells you what is the category. In this case, the category is avatar, and then follows by the value of the category. So avatar and then the URL. And we can expect the same treatment for the rest of the string. You can see how this is like one category, this is another category, right? So we can start to see all these things. So let's continue our decoding. Let's see, where have we stopped? We stopped at here, right, where we say there are 3 items in the array. This is the start of the first item. So now we're on item number 2. Item number 2 says skip 11 lines. So we're skipping starting from this line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines to skip. And this will be the next. So this is start of second item. And again, we see offset. So this is item 2A, right? Offset. Same thing here, right? We see another offset indicator. So this is item 2B. Again, we see this starts with a bunch of numbers. So this is a string, most likely. 3 converted from hex to int is still 3. 3 times 2 is 6. So 6 characters. Which means take the next 6. So 2, 4, 6, which is this. Convert this to a string, we get bio. There you go. Again, same structure where it tells you the category first, then it tells you the value. 33 converted to int is 51. 51 is 102. So 102 characters, which would be this. We get this, right? The first Web3 name service built natively on Monad. Oh, I guess what we got was the Monad's official metadata. I'm not sure. Yeah, right, just paste it there. We're done here. The next would be item 3, right? Remember we have 3 items here. Skip 18 lines. Starting from here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Skip, start from here. So again, start of third item, offset for item 3A, and this will be offset for item 3B. 5 here would be 5 times 10 is 10, and this would be 10 characters long. com.x, which is, by the way, very similar to ENS. ENS is also com.x. Where is it? I'm not finding it where, but you gotta trust me, bro, on this one. Okay, com.x. The next one, it will be a. So a converted to an int is 10. So this is 20. And 20 characters would be this one over here. Hex the string. Net domains. There you go. Beautiful. We have all this decoded. But of course, we need to convert this to SQL. How do we convert this to SQL? Good question. The answer is this, right? Where first you have to do this regex thing, gives me part. Remember the identifier bytes I mentioned earlier? This is where I used it. And then this is how you do offsets, right? You convert it to hex to int, and then divide by 32. And then I think the important thing here is that after you know there are 3 items, right? After you know there are 3 items, you can determine, you can make a CTE to grab just these 3 lines. Right, and of course this number can change. It can be 2, it can be 1, it can be 5 or whatever. So you need a way to programmatically or dynamically grab these 3 lines, and that's what I was doing over here. Right, I'm saying where is the what is the trace index number of the start of the offset and the end of the offset. And so if you look at here over here, it says position A, where index between offset A and offset A higher. So this is basically taking lines 3 to 5, or whatever this number may be. Why? Because I can then get the offset number, which is 3, 11, 18, and then all at the same time skip the lines and also get straight into decoding it. So if you were to rewrite this query and sort of follow through step by step, you would see that if, let's say, there are 3 items to decode, all 3 are decoding at the same time, right here, right in this one query. So I'm not decoding 1 item at a time, I'm decoding all 3 at a time. And that is only possible because we were able to extract all these 3 lines, or however many lines, to get the offset and apply all the offsets at the same time. So you can imagine, let's say this category length, right? This would mean over here, right? Right before we say we know it's avatar, we have the sorry, is this one over here? Right before we know it's avatar, we have the line telling us the number of characters for the string, and then the next line is the category, right? In this case, avatar. And so you can imagine decoding the word avatar, bio, and com.x is all happening at the same time in here, in this particular query, because we were able to do this dynamically. In fact, let me show you what this looks like. Oops. Over here. So I will just need to copy this transaction. I need to make it small, I can't see. Transaction. Let's look at decoding, right? So let's select all from decoding. Okay, so you can see that there are 3 rows, each row representing the number of items that is determined over here. And then if we go to the row, we can see all these numbers here, which changes dynamically based on these offsets, right? Skip 3, skip 11, skip 18, right? And see how we're able to decode avatar, bio, and then com, all in the same query, okay? And once we get all this, in the category name and also the value, I believe the value is here. Yeah, see, so it's category name and it's the value. And then how do I combine these two together? Well, first I would need to, well, I guess I don't need, I just need to use the object aggregate function, which would then combine, which will produce like a JSON column, so you can look up, the key value pair. What's the avatar, and then it's the link. What's the bio? This is the bio. What's the social handle? This is the social handle. Yeah, and the final query would be something like this, right? Where you can see all the attributes that are decoded. You can see some have 5, some have many, right? Some has just 1 like this. All the different information that people have doxed. And not sure if they know all these are on-chain and cannot be deleted. Anyways, so yeah, I think this is a very good example if you want to practice manually decoding. One thing that I wasn't able to do is tie all these attributes back to a particular domain. So something like this. Wait, is it this? All records flat. Wait. There you go. Okay. So something like this, where you have your token ID, you have who is the owner, what's the domain name, and what is the attribute or the latest attributes that is associated with the domain. I'm still not able to get all records. I'm only able to get 13. I'm expecting like a few thousand here. So I'm not sure what's up. If any one of you can figure this out, do let me know. But I think that will be the end of the video. I will put links to all of this in the description. And yeah, thanks for watching. Let me know if you have any topics you want to explore, and see you all next time. Bye.